So I think we shall start now. It's already 6:06. So please confirm whether my screen is visible. Please confirm whether my screen is visible or not. And my
No, ma'am.
yeah, just a minute. I'm sharing the screen. Is it visible now?
Yeah, visible, ma'am.
Yeah.
Yes, it is visible.
Okay. Thank you. So, welcome to the week 5 interaction session of Computer Integrated Manufacturing course, which is being instructed by Professor J. Ramkumar and Professor Amandeep Singh. And this is Chinmui, PMR scholar of IIT Madras. So, the assignment questions, I'll be discussing the answers and the ways in which way that have been designed. So, few of the questions I have taken and I'll be discussing on that. So, the first question in that assignment was given as on a workpiece rotating machine, the motion along the positive direction moves the tool. A fill in the blank is given the workpiece. So you can refer to the right side figure, right? So from that figure, you can say on that workpiece rotating machine, for example, you can take a lathe machine, which is shown in figure. So x-axis is the direction of the tool movement you can see from the figure itself. And that motion along its positive direction pulls the tool away from the workpiece. Why? Like in lathe machine, it has only two axes because that we know it has a spindle axis. Then you have that x and y. So this is the x direction of the tool motion. Then the tool moves in the direction of the positive x axis. So and it basically helps in preventing the tool from damaging itself from the workpiece and causing unwanted friction also. It prevents that unwanted friction also. So that is the advantages of having that, and that's the reason that workpiece rotating motion, that motion along that positive direction moves the tool away from the workpiece. So the right option will be the option C, that is away from. Okay. Then the next question is as y-axis is determined by x-axis and z-axis through the compass,
Left hand rule.
right hand rule, left hand rule, or ruler. What is the right option for that? What do you think?
Left hand rule.
Or right hand rule? Think what should be the right option for that? See, right hand rule actually is used convention in engineering because it allows to determine that orientation of three perpendicular axes, right? So to use that right hand rule, like you right hand, you make a fist, you can make a fist with your right hand, and then you can point your thumb in the direction of the first axis in that x axis, and your index finger in the direction of the second axis, that is your z axis, and then your middle finger will be the point in the direction of the third axis. So based on that you can get a reference to like understand the way. So here like when that programmer is facing the machine, you can assume that that's and that position x axis points to the right. So actually it follows some conventions, but not it, those processes are not universal. So x and y axis are orthogonal and z and x axis are fixed. So you can say like y axis will be determined by the z and x axis, okay, through that right hand rule. Okay, so that is the right option for that. So any confusion in that?
No.
Even you can refer this milling machine, right? So z axis is the along that spindle, and x axis you can see that, and y axis here. So those are parallel to that, sorry, perpendicular to that z axis. So you can refer to that your right hand, and from that also in figure you can see. So from that you can tell that how like y axis has been determined. So if you take your x and z axis, then you can easily determine that y axis. Okay, so that is the right option for that. Now in question number 3, it's given as for a fill in the blank is there. This machine, the cutter performs operation on the workpiece at specific points. Okay, so here I want to draw two parts, like basically that like numerical control machines, we can say there are like two types of NC programming as programming are there. One is point to point, one is path to path, sorry, continuous path. Okay, so if you like draw, just a minute, someone wants to join. Okay, so if you draw that x, say this is y. If you note this point as tool starting point, okay. So this is the tool start point or tool starting point, okay. So if you draw from here, okay, if you denote those points as P1, P2, P3, P4, and this is workpiece, workpiece, and it is a tool path, okay. This is the basic diagram, like if you can understand this from point to point. Say for example from P1 to P2, P2 to P3, P2 to P4, P3 to P4. Okay, this is the tool path, and this is that rectangular part one is workpiece, and this is the P1 is the piece, that starting point. Okay, tool start point. So this is basically point to point, point of that NC programming part, type. So in point to point programming, actually we are bothered about the starting point and ending point. We don't bother even about the path it which like traces towards the outputs, okay. So that you can move only one axis at a time. P2P, like that, it is basically the first primitive programming of in machine tool. So here, like from P1 to P2, P2 to P3, P3 to P4, if you mention like that, P4. So basically what happens, you can move only one axis at a time. Okay. So for that, like basically that in that continuous path, which is the another type, there, like, path which it has to generate is important here. So I'll draw that also, so you can understand from that. So if you draw here that, it seems like this kind of tool path. Okay, so those are the tool paths they are following. Here certain paths it is following. Okay, so in that path or traces you need to follow for generating like some samples or machining. So here that tool path or like path is important. Okay, so what happens, for that to control that path, you need to have some controller to control that path, or to generate that ultimate position, ultimate or machining condition. Okay, so here, like, you can say P1 to P2 or P6, or through that path P4. So those are the those are the basic example, or that schematic of that point to point or continuous path programming. Okay, so for that NC programming, here one question is given that for actually for point to point programming or NC programming, that cutter actually performs operation on workpiece at specific point. You can say from specific point it will start, and at a specific point it will end. So for cutter performance, that operation goes on a specific on that workpiece at a specific point. Okay, so the question was given as for a point-to-point machine, the cutter performance operation on the workpiece at specific point. So this will be the right option. Okay. So from the figure itself, you can refer this.
So, madam, can I intervene?
Yes, yes,
Yeah, point to point is like a drilling machine. If you take a
yes,
drilling machine,
yes,
so you
exactly.
have a series of holes, let us say.
Mm-hmm.
So one will have x1, y1, one will have x2, y2, one will have x3, y3, one will have x4, y4.
Yeah.
So this the cutter moves both direction actually x1, y1, and
Mm-hmm.
then performs the operation at one point, that is x1, y1. Okay.
Mm-hmm.
Next, it will go to x2, y2 and performs the operation. It's not only one axis movement; it is both the axis movement. The
Yeah.
operation, what happens is, the operation happens at only one specific point. Okay.
Mm-hmm.
So I am just adding to you.
Yeah, yeah, sure. Thanks. So, as he said rightly, that is like in this way that works, so that it follows that cutter performance follows in same manner that point to point like programming and C programming part. So that exact path of the tool makes in moving from point to point, like in that cutter is not always, it does mean that it is not always in contact with workpiece through the motion or path. Throughout the motion you can find that it is not always contact with that workpiece. So for continuous machine, like the cutter is mostly continue, even like for continuous NC machines, you can find sometimes that mostly in contact with workpiece during the motion cutter, but you can find that it will be every time it will be in contact. So here, like, that statement is given as the cutter is always in contact with the workpiece throughout its motion in a point to point. The statement, obviously it's a false statement, because the cutter moves from one to point and another to perform a specific operation to the workpiece. So as he said, like rightly sir, that during that motion there are the instances when the cutter is not in contact with the workpiece. So like even you can take as example as recently sailing that CNC drilling machine. So that cutter moves to a specific point to start drilling the hole, and during that movement between starting and ending points of that hole, the cutter is not in contact with the workpiece. Similarly, in CNC milling machine also you can find that cutter moves to a specific point to start cutting the material, and during that movement, like between, you can say, the different cutting points, the cutter may not be in contact with that workpiece. So that is the main like significance of that statement that has been
So it
addressed here. Yes, anything
uh,
you?
so
Yeah.
so point to point is used for location specific operations like drilling, boring, and continuous path is used to machine the geometry of the workpiece, right?
Yes, you can say it's sort of like operation. That's so. Then the next question is, the workpiece is affected throughout the toolpath in a continuous path machine.
True.
Yeah. So, like here, that we can say that
True,
the
no?
yes, the correct option is true, obviously. So because it is always in contact with the toolpath, like workpiece also, so it is affected throughout the toolpath in continuous path machine, which you have seen. So, which of the following tools can be categorized as a point-to-point machine? Okay, so like we have recently seen the example of drilling machine, right? So here, like in a hole drilling machine, that like drill bit moves from one point to another to create a hole, right, in that workpiece. So that from that point of view, can say, or we have as discussed like recently that currently on that. So the tool, like hole drilling machine only, the tool can be categorized as a point to point machine as we discussed above, right? So the right option will be hole drilling machine, because you can refer the machining principle of that also. So you can see the movement of the drill bit from one point to another point for creating a hole. So for that also can refer that. And the next question is, which of the following
All of
action
the above.
actions are described in NC programming? Yes. So basically, what does it happen that NC programming actually that describes the sequence of actions of controlled NC machine. So it could include, but not limited to, that functions which are given as tool selection one. So another one is tool movement, you can say, that includes direction, velocity, positioning of the tool. Then tool selection, you can say that tool change, then tool offsets or tool compensations, those performance are there in NC programming part. And then spindle rotation direction and spindle rotational speeds, those you need to control that. And then cutting speed for different sequences of operations which you need to perform together, or cutting fluid, application of cutting fluid wherever it's required. So those are the like actions or sequence of actions, we can say, those are controlled by NC programs. That is, so the right option will be all of these, right? So okay. Okay, now coming to that modal and non-modal comments. So here what happens that, like in your machine tool or like machine table, so origin is located at some position at machine tables, right? Usually it like at southwest corner or lower left hand, we can say the tables, but not necessarily. So the tool locations are different with respect to these zeros that we fix, that is called fixed zeros, or we can say that as world coordinate system. Okay, so and another like point is that floating zero. So there, like it basically follows that user coordinate system of work coordinate system, whatever we say. So that code, it follows that coordinates and that operates at 0 points in any position of that machine table. Okay, so it like one is fixed zero or like fixed point, which is being like specified at some position of that machine table, and with respect to that all the tool locations are specified. And another one is the floating zero, that is like at any point operator that sets that 0 point at any convenient position of that machine table. So like basically on that, by referring that, that comments issued in that NC programming may like in like that affects that referred as model comments or and non-model comments. So model comments actually you can say that includes feed rate selection and coolant selections, and another one is non-model comments. Oh, basically what happens there, uh, for that select like if you have, if like for example if you're trying to say like some xxx in example you have seen in lecture notes also, so it will be basically called as y. So wherever you see that y, you will like you have to interpret it as xxs throughout the whole document. So this is a kind of modal comment. Or sometimes you can say if you try to say small segment of program, you will follow this command. So that is non-modal command. So that is the basic difference between modal and non-modal command. Now what happens in that modal and non-modal comments? So just a minute. So that commands actually those are effective only when used, and whose effects are lost for subsequent commands are referred as non-modal commands. Whatever I have said in that example, say for example you want to say some small segment of that program, you will follow this command, that particular command. So that command we can tell as non-modal command. But wherein like in case of that like non-modal commands actually that do not remain active or in effect after they have been executed, they have been, say for example they have been executed somewhere in your part program, so they will not remain active in the or like in effect after they have been executed. So that they only affect the next in one, that NC program. So
Uh,
you,
I will intervene.
yeah,
It's like you have selected the coolant on. The
yes,
coolant on is M08. Coolant
okay,
off is M09. If you don't say coolant off, I mean, without, if you don't key in, I mean, if you don't have the program in the program M09, it continues to have coolant on. This
yeah,
is known as model. Like
yeah,
speed, I have put 1000 RPM, N 1000. Unless I change it to N 900 or N 800, it will not change again.
yeah, true,
So like that, even feed rate. For
yeah,
example, feed rate I have put F10, 10 mm per revolution or 10 mm per minute. So then unless I change it to F20, it will not change. It is
yeah,
known as mode. So you
yes,
key in something, so it will remember it there. It will remember in the memory, unless you change that value. Like if I have X value something, it will always remember as X value something. But unless you change the X value, it will not change. Okay, ma?
yes, yes. So by adding to that, like feed rate selection, you can say, or coolant, RPM, those are actually once you would like write at beginning of that program, throughout that program, whenever you write that, those are fixed. Like in the above itself of that programming, you will fix those parameters at speed selection, coolant or RPM. So those are fixed throughout your program. So that is basically like here one question is that which of the following comments can be referred as non-modal comments. So here you can say like you can see that speed, rate, coolant selection, RPM, as it rightly said, those parameters are fixed. So you can't like those are the fixed parameters, so you can say that those are model comments. So here the right option will be none of the above, right? Yes. So that next part is already we have discussed about comment and sorry, model and non-model comments. So comments that are effective only when issued and whose effects are lost for subsequent comments. Yeah, whenever we need that we will use, and after that it will be deactivated. So that is the main motto of that non-modal comments. So the right option will be the non-modal comments. Okay. So the next part is what does A represents in the manual part programming. Okay, so in manual part programming, A is like you have seen the chart itself, right? A is typically used to represent the angular direction. So around that x-axis, like that B and C, like that is given as angular direction around y and angular direction at around z. So those are similarly used to represent angular direction around y and z axis. Okay, so these axes are part of the machine tools coordinate system, you can say, or like it's basically used to specify the position and orientation of the cutting tool, which is relative to the workpiece. So by like mentioning that command in that NC program, then programmer can control the orientation of the tool and produce the complex shapes and features in the workpiece. So that is the like angular direction represent is the manual part programming x-axis. Okay. So and like basically that CNC program structures, if you say that four basic terms you can find like character, word and word, block and program. Okay. So like what does it specify for that character? Anyone like what is the significance of those character, word, block and program, so that you can find that code, you can like write your code for that. So anyone about that character, word, block and that program? So if you can like explain about those terms.
I mean, can you please repeat the questions once again?
Like here in CNC program structures, those are the like character, word, block, and diagram. Those are the basic terms in which that programming has been like written. So if like anyone can explain those terms by which you can say like, okay, this part is character, word, and this part is divided as word and block and that program. So that is the main question actually.
So I know about block. A block is a line of code which contains all the instructions. For example, the first block would be the first list of instruction like coolant on or tool selection, and workpiece is the actual workpiece to be machined, and um, character I think is the actual command.
Character is that digit or letter or symbol which you can
Yes,
see that by that
N
one.
M or a type of command which we are going
Yes.
to input in the CNC machine.
Yes, yes, or your word like is maybe a combination of alphanumerical characters. So this like creates a single instruction to the machine. So that is that word. Like it begins some capital letter or followed by some numericals or
Yeah,
numerals.
I just add ma.
Oh, yeah.
Any angular rotation about x-axis will be A.
Mhm.
Anything on B, Y will be B. Anything
Yes.
on Z will be C.
Yes.
It will be either you can call it as a swiveling or angular rotation. And
Yes.
additional axis also is there. Like x-axis parallel axis will be U, y-axis parallel axis will be V, z-axis parallel will be W.
Mm-hmm.
Okay, ma?
Yeah, yeah.
Yeah.
So here like some word addresses are there, those you need to like remember before that writing or like identifying the G code or M code says. So where A is now like it's mentioned that angular dimensions around X, Y and Z axis A, B, C. Then just a minute. So, and then F is the feet function, or G is that preparatory functions, H unassigned, I distance to arc center. Likewise, you can find all the like codes that M is miscellaneous function, sequence number is N. So those are the like functions which are given, those are the digits significance which are given in that. Accordingly, you need to like, for example, in this year assignment, one question was given when using a G90 absolute position, like, yeah, am I? Yes, no, no. One question was given is what does G17 denote in part programming? Yeah. So if you answer that question, so Z17 in like programming, that G code actually are used to control the machine tools movements and functions. So that G17 command is basically used to set the XY plane when the plane like as the plane of that movement, or we can say that subsequent tool movements in that xy plane. So basically G code signifies that the controlling of that machine tools movement. So
It's known as
you,
preparatory function. Mm.
yes, so line interpolation, circular interpolation, and dwell, like that. Those are G code commands are only. So they are actually different purposes they are being used. So like, but like they are one of like option there, those line interpolation, circular interpolation, dwell, and none of these four options maybe were given in that question. But here those like terms, that circular interpolation, line interpolation, dwell, those are not denoted by Z17 code, right? It's typically denoted by Z01, Z1, Z02, Z03. So that like for that question that answer will be none of them, because that G code is basically is giving the command to control the machine tools movement, but inside that for every operation there is specifically one code, that for line interpolation there is Z01, circular interpolation there is Z02, for dual I guess, if I'm not wrong, Z04 I guess, like that. So and another question was given from Z code itself was I is when using a Z90 absolute position command, each dimension or move is referenced from a fixed point, which is called. So basically what happens, that G90 command actually is used to specify absolute positioning mode. That means you can say all that subsequent movements are based on the machine's fixed reference points or absolute zero. So that point is set by the machine manufacturer, or like, and it serves that origin point of all the dimensions and movements which are append in that program. Okay, so that like using that absolute positioning mode itself, the programmer maybe like whenever you will be programming that part, then you can specify that exact positions and dimensions for that tool so that it can move. Okay, so that regardless that previous location, this can move, or this can like this can move forward, the tool can function. So that is useful for producing the parts with high precision and accuracy, which is the main motto of CNC programming. So this is the significance of G90 command, that it starts like from that absolute that point which is there, like when using using the G90 code absolute position command. So question was given, each dimension or move is referenced from that absolute 0 point. And some questions were given is from AM code also. So AM code is nothing but it's used to specify the feed that used to like control that various auxiliary functions of machine tools, such as spindle on off, coolant on or off, tool changes, or like that are not actually directly related to the tool movement. So basically it is being used to control that auxiliary functions of that machine tool. So here that question was given, M code is used to specify the feed in machining operation. So the the statement is true or false. This should that statement should like is false, right? False statement, right? M code is used to specify the feed in the machining operation. Is it so? It doesn't provide those that specify that feed rate, right? It provides the auxiliary functions of that machine tool spindles, not the feed rate. Feed rate in machining operation uh, actually specified by Z code commands, such as that we have that Z01, Z02, Z03. Those using that G command only, that feed rate is being specified. It actually that G code actually that commands control that movement of that cutting tool in different direction at different speeds to produce a desired shape and dimension of the workpiece. So for producing that dimensions speed, you need to provide some, for example, sometimes you need to provide some coolants for that, or you need to like on the spindle or off the spindle, or you need to change the tools. So for those operations, M code is given. So those commands are given, M code commands. Okay. So and one question was there is I, J and K codes specify that center of R coordinates from starting. That statement is true or false? I, J and K. What is the significance of that I, J and K codes? Anyone?
Or
Yes. Why that I, J and K codes are being used? What they specify actually?
IJK refers basically you want to perform a circular operation.
Okay.
Depending on the plane, your this I and the J and K will come into picture. Assume that
Yes.
you are in a XY plane, then you have a G02 or G03, your starting point and end point that you have to give I value, either I plus or minus, depending on the movement.
Yes.
Okay.
Yeah, it's like adding to that, actually, that is rightly said that to specify basically that center point of that circular arc, so which is in being related to that starting point of that arc. And
There is
like,
some, no,
yeah,
there is one more programming actually. Instead of IJK, there are some machines, they
mm-hmm.
use straight away one R.
Yes, yes, yes.
Okay. Instead of
Mm-hmm.
IJK,
Those are
I
actually initially primitive coding. They have commanded like that I, J, and K. Later, they have been like modified according to evolution. So in primitive coding part, we can see that I, J, K commands like so that
IJK
I,
is IJK is current.
yeah,
Primitive was sometimes some programming they use R. Okay.
but I can say like even nowadays also are that used. So I, J, K I can't find like in CNC milling it's being used. So don't think so other applications.
You will find them in circular operations.
Yes.
Any circular movements, you will find that.
So that I code also actually specify the distance along the x-axis from that starting point to the center of that arc, and the Z code is being specified that the distance along that y-axis, and K is like used to specify that distance along the z-axis for three-dimensional arcs. So together we can say that allows the programmer to like you can specify the exact center point of the arc. So, yeah, and one question was given is APT, that is automatically programmed tool. is APT type programming approach cannot be replaced by CAD or CAM approach. So that statement, like it's a what is basically that APT, automatically programmed tool. It's a type of that programming approach which like was in early days we can see it was being developed. So basically what does it do, like it uses some text based language to so that it can generate some part programs. So it was like time consuming, hectic, and like it was having some error also, so that basically it was being used as text based language. So in like, but CAD CAM is more, we can say, modern approach. It uses software tool to design parts and generate part programs automatically,
Ma'am,
so it is more efficient and accurate than APT type programming. So that's the
ma'am,
reason. Yes.
sorry to interrupt. I have one question.
Yeah, yeah.
Ma'am, how will artificial intelligence affect CNC programming and manufacturing? I mean, CNC is the most widely used machining method today,
Yes.
but how will AI contribute to it? I mean, can it write codes for us or suggest feed rate based on previous data or
Uh,
any parameters based on previous data or any defects or continuously monitor the parameters of the tools or anything?
Yeah, actually, in even in the field of artificial intelligence, you can add those CAD, CAM, or your like tool generated tool, that you can add those in a common interface, and you from that you can automate the system more efficiently, you can say. So actually, even you can send it to your data through cloud computing, or you can say, so those will be like automatically transferred to your system, and it will be again processed.
Yes.
So it is making the system more efficient or more precise, you can say. But this is the like main contribution nowadays of that artificial intelligence into the CNC and CAD CAM process. So
No, it
any,
is like no. 1 minute.
yeah,
Basically, the artificial intelligence is built in the CAD/CAM system, which will help you to arrive at the sequence of operations uh, based on the features of the part. Based on the features of the part, this intelligence has been built in the CAD/CAM system. What the other gentleman asked was this only. Okay.
I think he has asked the contribution of artificial intelligence in CAD CAM.
Yes. Yes.
Yeah. I feel
Overall,
I probably I answered him.
Yes.
both of you contributed to it.
Okay.
Actually, it like it analyzes that sets that information which you want immediately. So that's the reason actually it predicts your information, so like very quickly. That's the reason people are nowadays using artificial intelligence in like in your working. So mm, and that last question, what is there in that was, okay, which of the following is used as communication device to prepare MCU, that is machine control unit. uh, Options are encode, G code, F code, and none of this. So what is the right option for that? Which one is used as communication device to prepare MCU, that is machine control unit?
G code, right?
Yes, because G code, actually we have seen that G code is used to control the movement and functions of the machine. So data sent from a computer or like to that machine, machine control unit through that communication device. We can use that communication device as like some parallel interface, USB serials, or like Ethernet connections. So that interprets that G code and like executes that corresponding movements which you need to take, and then functions to produce that your required part or desired part. So that's how that works between the G code and that MCUs. So I think those are the questions are being addressed in this assignment and previous year assignment itself. So anyone is having any doubt? I think almost, or anyone want to explain something about that questions or something. So you can give any input, it will be useful to us only. So anyone like
Actually, ma'am, I have one question related to machining only.
yes.
So I wanted to ask you that as you know, we move on to more complex machines like in cars we use composite materials in certain places
Hmm.
like fiberglass.
Okay.
So how will machining change in the coming years? Like for us, like will there be more need for modern machining processes, guys like who know additive manufacturing or let's say who know more about composite materials, or CNC and other knowledge will be continue to be much more useful?
Can you repeat your question once again, like in a short, like
Yes,
additive man?
so
Yeah.
additive manufacturing and other modern machining processes like electrochemical machining, they are there. But
Yeah.
will replace CNC as the conventional machining processes in the future, like CNC or milling, drilling for producing complex shapes?
Uh, that CNC. You can like you want to ask that will that replace that CNC machining process? Am I correct?
All conventional machines.
Uh, that
You
actually,
touched uh, you touched three, four areas. One is conventional machine, another one is rapid prototyping machine,
yeah,
another one
another
is
the
CNC machine.
CNC.
As far as coming to rapid prototyping machine, earlier days rapid prototyping machine, now you call it as additive manufacturing. So additive manufacturing is totally taking the mileage, and you can reproduce a component. You can make a component straight away without machining, without machining. Whereas CNC machine still continues. In my opinion, it should continue for some more years. I mean, it will continue for some more years. I mean, decades, some more decades. It will not be able to. Additive manufacturing is totally different from a CNC machining.
Even I feel that in CNC you can get a more precise, like rather than what he has said, that electrochemical machining or like non-conventional machining, water jet, another. You can find if you mill some part using that water jet or some other machines, laser machining, and if you find mill some workpieces using conventional machining, though it takes time or tool like tool damages occur, even though that precision or that exact dimension it can measure, it can mill in precisely in CNC milling machine, so that precise way is there in CNC, so
No,
maybe
no, it's not the view. I mean, it's not the one what he wanted actually. He wanted whether it will
it will
replace
replace.
everything. Yeah.
See,
See,
CNC edited
additive
manufacture,
manufacturing. Additive
yeah,
manufacturing will not have the same surface finish whatever we have in a CNC
CNC,
machine.
yes.
A CNC machine. Although we can may bring in use a titanium or nickel or steel, still what my own experience, the surface finish will not be good in additive manufacturing. But certainly it will reduce the our time for making a model, time for manufacturing a component. Certainly, sometimes you really feel rapid prototyping is better. When you become a manufacturing engineer, you have to decide depending on the part what is that I want. Whether I want a NC machine, I mean CNC machine, or I want a rapid prototyping or a conventional machine. As a process man, as a process engineer, you have to decide.
Yeah, in a nutshell, we can say we can't even replace one system to other system, because those are the like other functionalities just depends on, so we
No,
can't say that we can replace one particular machine to other, so that like we can say completely we'll replace to that to additive manufacturing or other non-conventional smart manufacturing system, so it's, I guess it's not like the proper
no.
way to tell. what I feel that like.
Okay, thank you.
Any other confusion so that we can discuss, or any other talk, like explanation or description so that you can contribute to that class? Anything like, any other doubt or anything you want to discuss or explain? Any doubt?
Future will be more on the nano machining, because
Yes.
now we
Mm-hmm.
are talking about only microns, 10 micron. Uh, no, generally CNC machines, I'll always say that CNC machines can produce 10 microns and above.
Mm-hmm.
Only when you use jig boring machine, 5 micron and above. Then when you use a grinding machine, you will come closer to some microns, less than 5 microns. But as the days, as we are seeing now, new era will be nano machining,
Yes. Even
because
we are like, for example, we can say recently in our lab also we are producing nano texturing on the surfaces. So basically we are using for that laser because that femtosecond lasers and picosecond lasers are giving better surface finish with that nano texturing. So that is the
like that
reason.
only, that laser application of laser also on many areas.
Yes,
Like in
yes.
our engine parts, we make some breathing holes. So engine blades, we make holes with laser drilling.
Okay.
Laser drilling is used for that.
Anyway, are you using in your industry water jet for that cutting some
Water
part?
jet, basically for composites, you can use
No, you
water
people are
jet.
using in your industry in water jets. That's the question. Like that's a doubt I'm having that still people are using or not. Actually, I'm using
What it's not
water.
very widely, it's not very widely used.
Okay.
Basically, laser machine is used for cutting, and
Okay.
also water jet cutting. Water jet cutting, generally very rarely you find that machine, but in my opinion, it is used for uh, composites and also very thick plates,
Yes.
because
Also,
laser cannot cut more than not beyond 25 30 mm. I have not
Yeah.
seen any machine cutting more than 25 30 mm laser cutting,
Yeah. That's
particularly
true.
CO2 lasers.
Yes. True.
also, I have one question.
Mm-hmm.
So, in India, there are many investments for semiconductor manufacturing and aerospace parts. So, which machining processes or which manufacturing processes will be used for semiconductor industry? I've heard that first there's deposition for the p-n diode junction, then we use diffusion to create uh, that p junction and n junction in that silicon diode. But how as a mechanical engineering student I can get a job in those industries, semiconductor manufacturing?
Okay. Mm.
Unfortunately, in India, I have never seen this electronic parts, particularly manufacturing, is not studied by manufacture. I mean, mechanical fellows like semiconductor or even the PCBs, printed circuit boards, all these. Madam, you may be able to say
No,
as
actually,
a manufacturing as a
same same with me, same for me also, because I didn't have heard about like that mechanical people are, especially that manufacturing fields are being explored that.
it has become little gray area for mechanical engineers, particularly the electronic industry. Basically, like whatever you said, that semiconductor production and all. Mm.
because it is based upon our knowledge of material science and thermodynamics of, and also it is not called a factory but a foundry, semiconductor foundry. So I ask this question.
It's nowadays it's being explored. Actually, people are using that diamond machining or diamond turning for that semiconductor devices, or like I have heard about is being used. So it's quite explorable nowadays.
Actually, earlier days itself, people have done this MEMS, micro electromechanical systems, all that. But what I certainly, I do not know, having had some 35, 37 years experience in the manufacturing industry. Uh, Somehow we never came across anything on the electronic industry, basically.
But I have heard that people, like in research paper, I have seen that people are using now that water jet guided laser machines for semiconductor industries. Even they are manufacturing it to machine that devices.
They are
Like
using one kind of laser machining. It is not
yes,
laser. It is called ultraviolet lithography. So instead of using laser, it uses ultraviolet rays or energy to cut that nanometer chips.
yeah, even that water jet guided laser micro machining also is
Yes,
being used to cut semiconductor devices. That also I have
it's for
seen.
sensors and all that.
Yes, yes, I
But
have
for
seen.
processors and all, they use
Hmm.
ultraviolet lithography.
They are making some grooves on that disc material or size, like some dice materials. They are grooving it or some
The
smooth.
silicon wafer it is. It is
Yes,
the silicon
yes,
wafer.
yes. Wafer fractures, and that actually they want to avoid that breakage. What happens in that wafer fracture strength? So for that
Because
they
it
are,
damages the PN junction of the
yes.
other. Yes.
That's the reason they are using that water jet guided laser micro machining. So that I have seen as application. Other than that, I don't have that much idea on that field.
But in the aircraft industry, we use laser
Mhm.
even for marking on the looms. Looms means wires. Like in the aircraft, you will find kilometers of wire. Okay.
Yes, yes.
So for all the looms, we have a laser part numbering machine.
Okay. But laser is having some limitations also because it creates some subsurface damages in materials. So for that also it is quite difficult to use some post processing after that so that you can avoid that flame ignition which happens in that workpieces. So that also we are facing right now.
But
Yeah, it actually it
depends,
works well. Yeah, yeah.
depends on the usage, depends on the place of usage, all that.
Yes,
But
yes.
generally, more than this laser,
Mhm.
the one which I told you for cutting of the plates and other things, no?
Yes,
There it is more hazardous, like because of that CO2 laser. It is a
yes, yes,
carbon dioxide laser, so it will have more negative impact on the human beings. And another one is basically when you use the laser, Sometimes depends on the kilowatt of the laser. Uh, it will have heat affected zone.
Yeah.
Has it is known as heat affected zone. So
That's
there are
the
some
reason I have
implications.
told that due to that heat affected zone only that subsurface damages happen due to that flame ignition of that it catches actually fire in some materials. So
Mm.
that's the reason. So we need to do some post processing after that.
Uh,
Any
Probably
other? Yeah.
it's a high time that mechanical engineering should deal with this. Probably IIT should think of this to make a beginning. Because all of a sudden we are seeing many of the engineering colleges, people are not joining mechanical engineering. So it's high time that a lot of this type of engineering, electronics, manufacturing engineering should join with mechanical engineering.
That's the importance of that interdisciplinary part, interdisciplinary research we are like now interested to do. Like it's
Yeah.
good actually to explore. Anyway, any other doubt or any other queries or questions? Otherwise, we can close the session. So we can close today's session, right?
Thank you. Yeah.
Yeah.
Thank you, madam. Good day, ma.
Yeah. Thank you. Thank you.